We want to decide if you have a matrix A that's an m by n and you multiply it by the identity, you get the same result as if you take another identity, multiply it by A, which that result is A. Is this always, sometimes, or never the case? Well, from our examples, it seems like it might be always the case, but we'll need to prove it. And we'll actually need to prove two things. We will need to prove that A times the identity is equal to A. And we'll also need to prove that the identity times A is equal to A. And again, notice these identities aren't the same size unless m and n are the same size or equal. So let's see if we can prove this. And the way I'm going to do this is by slicing and dicing. So I'm going to let A be the matrix with columns A sub 0, A sub 1, and so forth, out to A sub n minus 1. And for the first part, I'm going to let the identity matrix be the matrix with columns E sub 0, E sub 1, and so forth, out to E sub n minus 1. In other words, the columns of the identity matrix are just the unit basis vectors, and there are n of them. So if I want to look at what A times the identity is, that's actually equal to A times the matrix with columns E sub 0, E sub 1, and so forth, E sub n minus 1. Well, the way we perform matrix multiplication, or one way, is to take the matrix A and multiply it by each of the columns of the identity to get the columns of the result. So, in other words, the product is going to be the matrix with columns A times E sub 0, A times E sub 1 is going to be the second column, and so forth. The last column is going to be A times E sub n minus 1. Well, A times any of the unit basis vectors just pulls out the corresponding column in A. So A times E sub 0, the first unit basis vector, pulls out the first column of A. That's A sub 0. A times E sub 1 is going to be A sub 1. And so forth. A times the last unit basis vector is going to be A sub n minus 1. But if I look at the result, the product is actually the matrix with columns that match A. So this is A, and that's exactly what I wanted to show. Now we need to look at what the identity matrix times A is and show that that's also equal to A. So all three of these will be the same matrix. Well, let's check. If I look at the identity matrix times A, again what I'm going to do is slice A by its columns. This is equivalent to the identity matrix times the matrix with columns A sub 0, A sub 1, and so forth, out to A sub n minus 1. Okay, the result is, well, that's a matrix with columns that are found by taking the identity times each of the columns of A. So the first column is going to be the identity times A sub 0. The second will be the identity times A sub 1, and so forth. The last will be the identity times A sub n minus 1. Well, if we notice, the result of taking the identity matrix times any vector is that vector back. So the first column of the product is going to be A sub 0. The second column is the identity times A sub 1, which is A sub 1, and so forth. The last column is going to be the identity times A sub n minus 1 or A sub n minus 1. But again, the result is a matrix with columns that matched the columns of A. So the result is the matrix A. Okay, we're done. That means that it is always the case that A times the identity times A is equal to A.